administration to augment the global positioning system, GPS, with the goal of improving its security, integrity, and availability. WAS can provide services for all phases of aircraft and all phases of flight, including en route navigation, airport departures, and airport arrivals. Let's consider WAS structure. The system WAS consists of space and ground segments. Space segment includes geostationary satellites that are pointed for transmission of navigation GPS-like signal, which will increase availability, accuracy, and reliability of navigation determinations. And also for retransmitting of the reports from the North about integrity of GPS and vectors of correction to ephemeral data, scale of time, and parameters of ionosphere model. The ground segment includes WAS reference stations, VRS, intended for control and for supervision of the state of navigation field. WAS master station intended for processing of data, monitoring and supervision received from WAS reference station. And ground stations of data transferring, which must carry out connection between WAS master station and geostationary satellites. So how it works? First slide. The signal from GPS satellites are received by WAS reference stations. There are more than 20 stations located on all territory of the United States. Each of these stations has an equipment and special software intended for the reception of GPS signals, analysis of received measurements, calculation of errors of ionosphere, trajectories, and satellite plots. The various locations are known with precise accuracy so that any errors in the received GPS signals can be detected by comparison of data about location received from GPS satellites with that of WAS reference stations. The next step is the GPS information collected by the WAS reference stations transferred to the WAS master stations via terrestrial communication network. At the WAS master stations, the WAS augmentation messages are generated. Then these messages contain information that allows GPS receivers to remove errors in the GPS signal. That gives significant increase in location accuracy. Then the augmentation messages are sent from WAS master stations to uplink station to be transferred to geostationary satellites. Next slide. And then geostationary satellites broadcast correct information on a GPS-like signal to users. Advantages of WAS. Every station effectively covers around the territory of radius of about 400-500 kilometers. So it gives the possibility to cover wider area with less ground station installed. Time of transferring of data from the base stations on geostationary satellites is a few seconds. In an operating condition, updates of data related to the clock and ephemeris errors are carried out with a period of about 2 minutes. The system provides error not more than 3 meters laterally and 4 meters vertically at 95% of the time. Control of integrity and capacity of GPS satellites. If for some reason GPS satellite starts to give wrong information or the errors of the navigation measurements exceed legitimate values, this satellite must be excluded from algorithm of the positioning calculation. All GPS receivers use information about the health of satellites with special fields of almanac and ephemeris, data of which is corrected from the ground GPS management stations 1 time per hour. So the ground segment of the system GPS cannot operatively react in the problem of in the work of satellites and carries information to users. But additionally, auxiliary system of WAS can pass this information in several minutes. Analogs of WAS. The European analog of WAS is called European Geostationary Navigation Overlay Service, EGNOS. EGNOS is intended for the improvement of work of the system GPS on the territory of Europe. It covers all Europe and some small European parts of Russia. And also there is an analog of WAS in Japan that is called Multifunctional Satellite Augmentation System, SAS, intended for Japan. So, thank you for your attention.